Hello students, today we are going to start remaining questions of chapter quadrilateral. Some short examples are remaining that we are going to see, and today it would be the last session of the chapter quadrilateral. So let us see the first examples of today. In this example it is given to us ABCD is a parallelogram. Means basically we have given that ABCD is a parallelogram in which P and Q are the midpoints of the side AB and CD. Okay, as you can see in the figure, P is given the midpoint of side AB while Q is given midpoint of side CD. Then they are saying that AQ intersect DP at S and BQ intersect CP at R. Means if you look the line BQ, then BQ and CP are intersecting at a point R while AQ and DP are intersecting at a point S. Then we have to show that here. First one, APCQ is a parallelogram, DPBQ is a parallelogram, and PSQR is also a parallelogram. Okay. Here one thing you need to remember while solving this question, some of the fact we should know. First of all, if we want to prove a parallelogram, what are the available ways we have? So I am writing here one by one. Please remember, first way is if you want to prove a parallelogram, then both pair of opposite side should be parallel, then it will be a parallelogram. One thing. Second, one pair of opposite side, any one pair of opposite side, means you take any one pair and it should be parallel as well as equal. Means for example, if I want to prove ABCD is a parallelogram, I am taking the example ABCD because it can be easily seen. Okay, so ABCD is a parallelogram, I want to prove it. So according to the way number 1, I need to prove AB and CD are parallel, and in addition to that, I also need to prove AD and BC are also parallel. Okay. Second way is you take any one pair of opposite side. For example, I have taken AB and CD. So I need to prove here AB and CD parallel as well as AB and CD equal. Okay. So these two ways you remember it would be required when we are proving these three parts in the parallelogram. Okay. In one or two part we may require the first way or second way, and remaining part we require the second way. Okay, so let us see whichever is applicable. So first we are writing the given. What is given in this question? So first I am writing the given over here. In the given we have ABCD is a parallelogram. First, ABCD is a parallelogram, that is the one given. Second, we have given that P and Q are midpoints of sides A and CD. They are given the midpoints of the sides AB and CD. Okay, to prove. Now what we need to prove here, that we will mention here. So we need to prove here APCQ, 1, DPBQ, second, and PSQR. These three we need to prove as parallelogram. Okay, now let us see how we can prove it. First of all, let us start part number 1. APCQ we shall prove as parallelogram. Question is simple, it is not tough. Only the two ways I told you in the beginning that you need to remember. First, we shall write down, since P and Q are midpoints, of AB and CD. So therefore, we can say that AP will be half of AB. You can see in the figure, AP is one of the part of AB Okay, and similarly I will show you the figure properly. Look at the figure. You see AP and PB are the two parts of AB. So one part definitely will be half of the whole. Similarly, observe CQ and DQ are also the two part of CD. So we can say that sorry, we can say that CQ will be also half of CD. So here we can write down second one, CQ will be half of CD. Now, observe ABCD is given as a parallelogram, and we know that in a parallelogram, side opposite to each other are always parallel as well as equal. So AB and CD are equal. So look at the two equations I have written. I have written AB, half of AB in one equation and half of CD in another equation. So if AB and CD are equal, their half will be also equal. Means we can say that here, but AB is equal to CD because opposite sides of parallelogram. Opposite sides of parallelogram will be always equal. So since now it become the right hand side of these two equations, which two equations? AP is equal to half of AB and CQ is equal to half of CD. These two equations, their right hand side are same, so we can say their left hand side will be also same. So AP will be equal to CQ. Now one more thing we have, okay, we can write down here also AB is parallel to CD. So we can say that since AB and CD are parallel, which means that AP is parallel to CQ. See how AB and CD can be parallel here, because you see ABCD is a parallelogram. So AB and CD will be parallel. Then how we can say that sorry, AP and CQ will be parallel? Because AP is a part of AB and CQ will be part of CD. So we can say that AP and CQ are parallel. Okay, so AP and CQ are parallel. One more thing you observe, we have proved already here, AP and CQ are equal. And as I told you in the beginning, if we are able to prove any one pair of opposite side equal as well as parallel, we can say that it will be a parallelogram. So we can say that therefore APCQ is a parallelogram. Okay, if you want to write it down for yourself, you can say that since AP is equal to CQ and AP is parallel to CQ, that we have proved earlier. Okay, and we can say that one pair of opposite side I have proved parallel as well as equal. So it will become a parallelogram. Now you see the second part. Second part also we can prove in the similar manner. You observe we need to prove here DPBQ is a parallelogram. So if I take in the similar way BP and DQ, I can prove easily equal because BP is half of AB and DQ is half of CD. Again AB and CD are equal, so BP and DQ will be also equal. Second thing, BP and DQ are parallel also because AB and CD are parallel. Okay, so here we can say that in the similar way we can prove that DPBQ is a parallelogram. So we will write down here similarly we can show that DPBQ is a parallelogram. Okay, so this will become the second part. So here you can say proved first and second, that we have over here. Now remaining is only third part. Okay, so we'll see now part number third. So let us see in the part number third what exactly we need to prove over here. You can see they are asking show that PSQR is a parallelogram. PSQR is coming one quadrilateral inside the parallelogram ABCD. It is coming exactly in the middle. Okay, So first of all, see, we have proved already APCQ and DPBQ is a parallelogram. So if I talk about APCQ is a parallelogram, then you observe AQ and CP. You observe this line, AQ and CP are already parallel because APCQ is parallelogram. Now the part of AQ and CP will be also parallel. So who will be the part of AQ? Observe the line SQ and the part of CP will be PR will be also parallel. And similarly we can say that SP and QR will be also parallel because DPBQ is also a parallelogram. So their opposite sides will be parallel and hence the part of the opposite side will be also parallel. And we get the both pair of opposite side of a quadrilateral are parallel and we can say it is a parallelogram. So let us see how we can prove it. First of all, we shall write down APCQ is a parallelogram, therefore AQ and CP are parallel. So first let us finish the first part. Now since APCQ is a parallelogram, therefore AQ is parallel to CP. What reason we can give? Opposite sides of parallelogram. Opposite sides of parallelogram are parallel. Okay, so we can say that AQ and CP are parallel. You can see once AQ and CP will be parallel. Now we shall take a part of part of AQ and part of CP. So who will be the part of AQ which is useful for us? That will be SQ because our ultimate task is to prove that PSQR is a parallelogram. So here we have one part SQ and another part of side CP will be PR. So we can say that SQ and PR will be also parallel because they are the part of AQ and CP. So here we can say that which implies that SQ is also parallel to PR. Now we will write down further. Also DPBQ is a parallelogram that we have proved. DPBQ is a parallelogram. Okay, so in that also we will get the opposite sides are parallel. So now in that we shall take, observe DPBQ I have taken. Okay, so in DPBQ if I take DP is parallel to BQ, so I will get PS is parallel to QR. So we can say here, first of all we shall write down DP is parallel to BQ. Therefore, we'll write down DP is parallel to BQ. The reason would be same, opposite side of parallelogram. So no need to write down again and again. So we can say that therefore PS is parallel to QR. And now you observe we got both pair of opposite sides parallel in the parallelogram PS in the quadrilateral PSQR. So we can say that therefore PSQR is a parallelogram. If you want to write down the reason, you can say that since both pair of opposite sides are parallel. Okay, so this complete the question. Now let us see the next example. So now we are starting the example number 7. Yes, in the example number 7 we have given that in triangle ABC, D, E and F are respectively the midpoints of the sides AB, BC and CA. Okay, we are looking the three sides of the triangle ABC here And for the three triangles, we have given that D, E and F are the midpoints. Means AD and BD are equal, BE and CE are equal. Similarly, AF and CF will be also equal. And they will be the half of the main side, that is AB, BC and CM. Now, if they join D to E, E to F and F to D again. So you can observe one more triangle, sorry, one more triangle is going to form inside the triangle ABC. Then we can say that here that triangle we have to prove it divides into four congruent triangles. Means actually you have to prove that triangle ADE, triangle DBE, triangle DEF and triangle CFE. These all triangles you have to prove they are congruent to each other. Okay, these four triangles you see in triangle ABC, now four triangles are going to form. One triangle is ADF, second one is BDE, third one is DEF and last one is CEF. Okay, so these all four triangles we need to show they are congruent to each other. So let us see how we can prove it. This question we shall prove it by the midpoint theorem. I hope the midpoint theorem you remember it very well. Once again we shall recall. So first we shall write down the given. We can say that in triangle ABC the given is very simple. We have given that three midpoints. So we can say D, E and F are midpoints of respective sides, or you can write down the name of the side also. In short, I have written respective sides. Now what we need to prove here, as I told you, these four triangles we have to prove they are congruent. So we'll mention here to prove triangle ADF is congruent to triangle BDE is congruent to triangle CEF. Sorry, congruent sign is remaining. So is congruent to triangle CEF and is congruent to triangle DEF. Okay, so this we need to prove it. Once we shall recall what exactly a midpoint theorem says. See, in midpoint theorem we have learned, suppose we have given that one triangle. I will draw a simple triangle over here. Suppose this is a triangle given to us. Okay, and the name of triangle, suppose if I take PQR, and suppose we have given that two midpoints L and suppose if I say M. So L and M are the midpoints of side PQ and PR. Okay, L is a midpoint of PQ, M is a midpoint of PR. That is given in the question. So when you join the line LM, then we know LM is parallel to the opposite side, that is QR, and LM will be half of the side QR. Okay, means whichever is the side is opposite to LM, it will be parallel to that and it will be half of the QR, that we knows. So now see how we can use the midpoint theorem over here and we can find out the required solution. So first of all, we shall take here one quadrilateral. See, there are some quadrilaterals you are seeing inside the triangle. That is a unique case here. But yes, it is true. You are seeing some quadrilateral. For example, one quadrilateral is BEFD. Look at the quadrilateral carefully. BEFD. One more quadrilateral is there. That is CEDF. Okay, or CFDE, whatever you want to say, the sequence. And one more quadrilateral is there, ADEF. Okay, so I want to say only there are not only one quadrilateral, there are many quadrilaterals given inside the triangle. We shall consider the quadrilateral BEDF. Okay, in this quadrilateral, first of all, we shall prove this quadrilateral is a parallelogram. Okay, why we shall prove it, that you will come to know little later. First of all, let us prove this quadrilateral is a parallelogram. Okay, for that, how we can prove it? As I told you in the last question also, if I want to prove a given quadrilateral is a parallelogram, then we have basically 2 to 3 ways. 2 ways already we have seen in the previous question. You show that both the pair of opposite sides are parallel, or show that one pair of opposite side is equal as well as parallel. Okay, it is also possible. So see how we can use any one of this way, whichever I have told you, and prove that BDFE is a parallelogram. First of all, we shall write down in the solution in triangle ABC, we can say that D, F are midpoints of AB and AC. Is given in the question. Okay, that is clearly mentioned in the question that D and F are the midpoints. So now if I apply here midpoint theorem, so by midpoint theorem, okay, so midpoint theorem, what it says? It says D and F, if they are midpoint, so DF will be parallel to BC and DF will be half of BC. So we can say that therefore DF is parallel to side BC and DF is equal to half of BC, right? That is one result we got with the help of midpoint theorem. Now you see already DF is parallel to BC, then DF will be parallel to BE also. So we can say that if DF is parallel to BC, then DF will be equal to BE as well. And one more thing, DF will be half of BC. So we have BE is equal to EC is equal to half of BC. That is already have. How we can say? Because we have given that E is midpoint of BC. So that we can say, the second equation I have written here, that because of E is a midpoint. Now you observe these two equations, this one and this one. DF is also half of BC and BE is also half of BC. So we can say that DF and BE will be equal. So here we shall write down, sorry, here I have written by mistakenly equal. We shall make it parallel. Sorry, here by mistakenly I have written as equal. So DF and BE are parallel over here, one thing. So we can say that therefore DF is parallel to BE. That we got the help of DF parallel to BC. If parallel to BC, so their part DF is parallel to BE also. Okay, and here with the help of this conclusion, we can draw here DF is half of BC and BE is also half of BC. So we can say that DF is equal to BE. Now let us see the quadrilateral BDEF. Observe the quadrilateral BDFE. Okay, in that you observe we have one pair of opposite side, that is DF and BE. DF and BE, you observe we have proved parallel as well as equal. Check it down over here. DF and BE are parallel and DF and BE are equal as well. So we can say that therefore B, we'll see the sequence BFDE, or what they're saying BDFE, sorry, BDFE is a parallelogram. BDFE is a parallelogram. Now see, I have told you, you will come to know little later why we have proved this one is a parallelogram. Why we are proving it is a parallelogram? Because one theorem is there in a parallelogram, we know that the diagonal divides it into two congruent triangles. See, BDFE is a parallelogram, and you observe in the figure DE is a diagonal. So DE will divide the parallelogram into two congruent triangles. This theorem we have proved it earlier also. This is the only single theorem we have proved in the chapter, and its proof also can come in the examination. So see here, now we shall apply that theorem. So we can easily say that triangle BDE and triangle DFE will be congruent here, because we know that as per the theorem, the diagonal divides parallelogram into two congruent triangles. So here which two which two triangles we got here? Triangle BDE and triangle DFE. So here we can say that therefore triangle BDE, triangle BDE is congruent to triangle DFE. How we can say? That is, since in a parallelogram, diagonal divides it into two congruent triangles. Okay, that we knows. So now we can say triangle BD triangle BDE and triangle DFE are also congruent. Now see, as I told you, there are many quadrilaterals inside the figure. So you observe CEDF. CEDF is also one of the quadrilateral. So in that we can show CEF and DEF will be also congruent. Okay, so here we shall write down similarly CEDF and ADEF. CEDF and ADEF. We can say that similarly CEDF and AEDF are also parallelograms. Okay, in the similar way as we have proved the parallelogram BDFE. Now CEDF is a parallelogram, then which two triangles are congruent? CEDF. Observe, the two triangles will be CEF and DEF. So we shall write down here CEF. Therefore, triangle CEF is congruent to triangle DEF. Okay, this is our equation number 1, and this will be equation number 2. I think in the equation number 1 it is written DFE, so we shall make it proper. It is BDE, so BDE and FDE we shall write down in this manner, or otherwise if you want to write down DEF, so because we are writing the second equation DEF only, so it is better we shall write down with one-to-one correspondence. Okay, so here BDE and DEF, sorry, FDE, that way we shall write down BDE, that is one is right and second one is FDE. Here we shall make correction, this one. Okay, because it is not one-to-one correspondence, so since we are writing the triangle's name, it should be as one-to-one correspondence. So this we shall write down as triangle FD. Okay, now we shall write down similarly the second one. We have proved AEDF is a parallelogram. So who will be the part of AEDF here? AEDF, you observe triangle ADF and triangle DEF again will be the two congruent triangles. So we will write down now here ADF and EDF will be the two congruent triangles. So here we shall write down, therefore triangle ADF and triangle ADF is congruent to triangle EDF, will be also congruent. Now observe the equation number first, second, third. See, the right hand side is same. FDE you say, DEF you say, or EDF you say. I have written correspondingly same triangle with the another one. So if we compile the equation first, second and third. So by equation first, second and third, we can say that triangle BDE is congruent to triangle CEF is congruent to triangle ADF is congruent to triangle EDF. See how we can say, because these all the three triangles BDE, CEF and ADF, they are commonly congruent to the triangle DEF. So therefore they all will be also congruent to each other. Now let us see the next question. Now we are going to solve this last example, that is solved example number 8. This is the last example, and after this our chapter will get over. In this chapter we shall use the converse of midpoint theorem. So if once again we can discuss what is exactly a converse of midpoint theorem, and then we'll follow the solution. Okay, so suppose if I have one triangle and the name of this triangle, suppose if I take the name, if I take as ABC here, okay, and suppose on the side AB if I take one point M, and if I say AM and BM are equal, means M is a midpoint of AB, that is given in the question. Okay, so please be remember, when we are going to apply the theorem we should have a certain given. Okay, accordingly only we can apply the theorem. So here first given you required, on one side of the triangle you required one midpoint. From that midpoint, if you draw a line to another side, then we will get here one line. The name of the line is MN. Okay. The second given you want here, that MN should be parallel to the BC. So suppose if I classify here given, so given will be first given you required M is a midpoint of respective side, or you can say that here midpoint of side AB, and the second given you want here, that is MN is parallel to the base BC. Then as a result what you will get here, the result will be N is a midpoint of side AC, that you will get as a result. This is your converse of midpoint theorem. We have done several times earlier also this theorem. So remember, two given you want, M is the midpoint, one midpoint is required. From that midpoint you should draw a line parallel to the base, and that from that midpoint whatever the line you have drawn, that line will be touching the another side, that will be also a midpoint according to the converse of midpoint theorem. So if you satisfy these two given, okay, so as a result you will get N will be also a midpoint of another side. Okay, so now here let us start the question. First of all, you can read the question carefully. See, in this question we have given that L, M and N are three parallel lines intersected by a transversal P and Q. Transversal, you know it very well, which intersect the parallel lines. Maybe unparallel lines also they intersect, but the line is intersecting a pair of line is called as the transversal. Now they are saying here one given is there, L, M and N are three parallel lines. So first I will write down the given things, what is given to us. So here we have given that L, M and N are parallel lines. Okay, that is one given. Second, you see they are saying such that L, M and N cut off equal intercept AB and BC. What is intercept? When the transversal intersect the pair of lines or the parallel lines, the length of the transversal which remains between the two parallel lines is called as the intercept. For example, look at the line L and M. So line L and M, between line and M, the length of the line P is remain over here as AB. So sorry, so we can say that here AB is one intercept. Similarly, BC is another intercept. We can say that AB and BC are those intercept which is made by the transversal P onto the line L, M and N. Similarly, the line Q is making the two intercept, that is DE and EF. In the question, we have given that AB and BC are equal. So here we have one more given, AB and BC are equal. Now what they are saying? Show that LMN cut off equal intercept DE and EF on Q also. Means we have to show that the intercept DE and EF are equal. So DE is equal to EF. Now let us start the proof. How we can prove it? As I told you earlier and I have explained to you also. So we will prove this question with the help of converse of midpoint theorem. Okay, so let us see how we can prove it. First, you can see in the figure, I am taking one triangle. The name of triangle is triangle ACF. Okay, in this triangle, first of all, you see B is a midpoint of AC. Can we say like that? B is a midpoint of AC? Definitely. You can see in the given we have already A AB is equal to BC. And since AB and BC are equal, we can say that B is in the middle of the AC because B to A and B to C, it is same, and hence in the other words we can say B is a midpoint of AC. And one more thing, can we write down BG is parallel to CF? Look at the figure carefully. Can we say that BG and CF are parallel? Definitely yes, because we know that since M is parallel to N, M and N are parallel, so the part of the part of the line M and the part of the line N will be also parallel. And see here we have fulfilled the condition of converse of midpoint theorem, because in the converse of midpoint theorem we required one midpoint, and from that midpoint we should draw a line which should be parallel to the base. So we can say that from that midpoint we have drawn a line onto the another side, that is AF. So G will be also a midpoint of AF. So that we will mention here now. Okay, so here we will say that therefore by converse of midpoint theorem, by converse of midpoint theorem, we can say that G is a midpoint of AF. Okay, now see we have got here one important result. Now see, once again I am taking one another triangle. Same theorem we shall apply, converse of midpoint theorem, but it will be applied on a different set of triangle. Now look at the triangle AFD. AFD, you look at carefully. Okay, now in the triangle AFD, G is a midpoint of AF. Just now we have proved. And from the point G, we have drawn one line. The name of line is GE. Can we say that GE is parallel to AD? Definitely yes, because L and M are parallel. So again same concept, the part will be also parallel. So GE and AD will be also parallel. Now from the midpoint G, if I draw a line, then we can say that the line is drawn onto the another side which intersect at a point E, and hence A will be sorry, E will be also the midpoint of the side DF, and that is why we got the required result here. If E is the midpoint of DF, means DE and EF are equal. So let us see how we can write down these things. First we shall write down in triangle AFD. So here now we shall write down now in triangle AFD. Okay. Now in this triangle, first of all we shall mention who is the midpoint we have of one side. So we'll say that G is a midpoint, D is a midpoint of AF. Reason can be given here, proved earlier, because we have proved in the earlier section, so can be written here as proved earlier. Now see one thing we have written about the about in this triangle AFD. Observe G is a midpoint of AF, and one more thing, GE is parallel to AD. How we can say GE is parallel to AD? I have told you earlier, L and M are parallel. That's why the part of L, that is AD, and part of M, that is GE, will be also parallel here. So we'll write down further, and GE is parallel to AD. GE is parallel to AD. We can say since L is parallel to M. Okay. Therefore, again by converse of midpoint theorem, by converse of midpoint theorem, by converse of midpoint theorem, we can say that F is, that will be F or any other point, we can check once. So here observe E will be midpoint of DF, because another point is coming on to the another side, is that is E. So E will be midpoint of DF. So we can say that here E is a midpoint of DF. Okay, or we can say that here DE is equal to EF. Okay, that is only required to be proved in the question. So students, we have finished all the solved example also of textbook, whatever and wherever it is required. I have given you the solution of all the examples. Now you start preparation of the class test. The class test will be conducted very soon.